Good afternoon, this is Schweitzer, and this is a few workbook problems looking at just some ins and outs of solubility reactions. All right, first things first. All right, so we've already done some of these hopefully, but it says sodium chromate and lead nitrate are mixed together. All right, so it wants the molecular, ionic, and net ionic equations. I got one example here. So sodium chromate is going to be Na2CrO4 plus lead nitrate Pb parentheses NO3 parentheses 2 yields lead chromate. Now this is a -1 plus 2 -2 plus 1. With a solubility reaction, there's no change in charge, which we'll see happening in oxidation reduction reactions. You do have change in charge, which means you have changing of electrons, but this is not the case. The charges stay the same all the time. All right, so we're just going to see if the lead can be precipitated with the chromate. So it's CrO4. This is a +2. This is a -2. That's a 4. All right, plus we have sodium nitrate, NO3. Going to be skimming over some of this stuff a little quicker. This one's a quick check, would be aqueous. And I'm assuming this one here would be a solid. I don't believe that the lead chromate is on the solubility chart, but I'm pretty sure it's going to be a solid. All right, now the ionic equation is really showing ionic compounds as they actually are. This really is what a beaker would look like. We just hopefully we did that classroom activity kind of drawing what a beaker actually looks like. And that's what this is going to be. So ionic compounds that are dissolved are actually separated. So Na plus CrO4 -2 plus Pb2 plus NO3 -1 yields. Now this guy is actually forming a solid, so I'm going to leave it together. PbCrO4 plus Na plus NO3 -1. There we go. That's the ionic version. Almost never have I ever, especially not in an advanced placement test, I almost never see this asked. But again, it is how you would use to draw a pictorial diagram in a beaker. So it is probably the most accurate what's showing. All right, net ionic. It's going to remove what's called the spectators, the things that don't do anything. Things that are exactly the same on both sides. The sodium nitrate, these are completely unchanged, and therefore they would be removed. We call these spectators. All right, therefore my net ion equation is simply a lead ion, Pb2 plus, and a chromate ion, CrO4 -2, forming PbCrO4. Again, this would form a solid. That would be optional at this point. I guess if you want a solid there, it's up to you. In a net ion equation, together is in fact indicating a solid. All right, anyways, with that being said, you could always pause this video. I'll do one more here, and then you can pause it and try it on your own. All right. We have ourselves lead to nitrate. So Pb lead nitrate, potassium sulfate. All right, so we're going to have KNO3. This is going to be aqueous. And then we have plus lead sulfate, PbSO4. All right. Next is going to be the ionic version. I'll put this below over here. Pb2 plus NO3 minus 1 plus K plus, everything's dissolved, plus SO4 minus 2 yields PbSO4 plus, then my two spectators, K plus NO3 minus. Removing my spectators of the potassium nitrate, my net ionic equation is Pb2 plus SO4 minus 2 yields PbSO4. Of course, again, this is my solid. That would have to be verified typically by some solubility chart. I showed that in an earlier video, so I am not going to harp on that too much right here. Make sure you're using your solubility charts. If there's no new substance formed, then there's a no reaction. Thank you.